The boundary condition of the universe is that it has no boundary.
Okay.
In order terms, the Euclidean space-time is a closed surface without edge, like the surface of the Earth. One can regard imaginary and real time as beginning at the South Pole, which is a smooth point of space-time where the normal laws of physics hold. There is nothing south of the South Pole, so there was nothing around before the Big Bang.
For over 50 years, the story of the universe seemed settled. It's a story we all know. A Big Bang, 13.8 billion years of cosmic evolution, all leading to the universe we see today. This foundation, called the Standard Model of Cosmology, has been one of the most successful theories ever developed. Then came the James Webb Space Telescope. It was built to peer back to the cosmic dawn and test the first chapter of this story, to see the birth of the very first galaxies. Instead, what it found is threatening to unravel everything. And recently, a Nobel Prize-winning scientist, Adam Rees, issued a grave warning. We may have gotten the universe completely wrong. To understand why cosmologists are so concerned, we first need to look at the elegant picture they had painted. It's called the lambda CDM model, or lambda CDM for short. It tells a straightforward story that begins 13.8 billion years ago. From an infinitely hot, dense point, the universe expanded and cooled. For a few 100,000 years, it was an opaque fog. But as it cooled, the first atoms formed, mostly hydrogen and helium, and the universe became transparent. The faint afterglow from that moment, the cosmic microwave background, is like a baby picture of our universe and a cornerstone of Big Bang theory. According to lambda CDM, the next few 100 million years were the cosmic dark ages. The CDM stands for cold dark matter, an invisible substance believed to make up about 27% of the universe. This dark matter provided the gravitational scaffolding for everything to come. Slowly, gravity pulled gas into dense clumps, which ignited the first stars. These stars then grouped together, forming the first primitive galaxies. The model predicted these first galaxies would be small, clumpy, and disorganized, the humble seeds of the grand galaxies we see today. This model has been incredibly successful. It predicted the patterns in the cosmic microwave background with stunning accuracy and explained the large-scale structure of the cosmos. For decades, every observation seemed to fit perfectly. Then, we launched JWST. JWST was designed to test this very origin story by looking at the most ancient corners of the cosmos. But that's not what happened. When JWST looked back to just a few 100 million years after the Big Bang, it didn't find the small baby galaxies it expected. Instead, it found galaxies that were shockingly massive and well-formed. It saw galaxies with mature structures, like disks, which shouldn't have had time to develop. What makes this discovery truly astonishing is finding this level of organization in a cosmic era when most galaxies should have been chaotic and unsettled. The timeline was wrong. Interestingly, more recent analysis suggests some of these galaxies aren't as massive as they first appeared. The intense light from actively feeding supermassive black holes at their centers might be making them look bigger and brighter than they are. However, even with this adjustment, a problem remains. There are still roughly twice as many massive galaxies in the early universe than our best models predict. They may not be impossibly big, but they are far too numerous. So why is finding too many large early galaxies such a big deal? It's a fundamental contradiction. The Standard Model has a clear cosmic speed limit for how fast galaxies can form. It takes time for gravity to gather enough gas, for that gas to cool into stars, and for those stars to forge the heavy elements needed for complex structures. The galaxies JWST is finding appear to have broken that speed limit. This is where the warnings from top scientists come in. John Mather, a Nobel laureate and a senior project scientist for JWST, admitted his surprise. He said the first galaxies are not quite like what we thought they were, describing them as surprisingly big, bright, powerful, and numerous compared with what we expected. But wait, the warnings become even more stark when we turn to another Nobel laureate, Adam Riess. Riess won his Nobel for co-discovering that the universe's expansion is accelerating. For years, he has been at the forefront of another major crack in the Standard Model, the Hubble tension. This refers to the fact that two different methods for measuring the universe's expansion rate give two different answers. One method, using the cosmic microwave background, points to a slower expansion. The other, using nearby stars, measures a faster rate. Scientists hoped JWST would resolve this tension. Instead, its more precise measurements have only confirmed the discrepancy is real. Speaking about these combined problems, Riess has been direct. He stated that the discrepancy has to make us wonder if we really do understand the composition of the universe and the physics of the universe. He went on to say that these findings leave us with the real and exciting possibility we have misunderstood the universe. Think about what that means coming from a scientist who helped define our modern cosmic model. It's an admission that our understanding of the universe's foundational ingredients might be wrong. If the expansion rate is different, the age of the universe could be different. If galaxies formed too fast, our theories about dark matter might be incomplete. The problem isn't a small inconsistency, it's a cascade of anomalies pointing to a deeper mystery. So if our best model is cracking, what comes next? A crisis like this is the beginning of a hunt for what scientists call new physics. There are three main paths forward. Possibility 1. We just need to tweak the model. This is the most conservative option. It suggests lambda CDM isn't wrong, just incomplete. Perhaps the first generation of stars were cosmic behemoths that jump-started galaxy formation at a much faster rate. Another idea is that galaxies are fed by cosmic rivers, vast, unseen filaments of cold gas streaming through space, providing extra fuel to the galactic engine. Researchers are re-examining the data, suggesting that bright active black holes are contaminating the light from some galaxies, making them appear more massive than they are. Possibility 2. The universe is not what we think it is. This path is more radical. What if the problem is with the universe itself? The Hubble tension could be a major clue. Some theorists have proposed a form of early dark energy that gave the universe an extra push right after the Big Bang, speeding up the timeline for galaxy formation before disappearing. Another idea questions our assumptions about dark matter. We assume it's cold and slow-moving. What if its properties have changed over time? Adam Riess himself has said that pinning down the expansion rate will help determine if the force we call dark energy is constant or evolving, a discovery that would be monumental. As a result, some scientists are exploring another possibility, that our galaxy sits inside a giant cosmic void, which would make the local expansion of the cosmos appear faster than in other regions. Possibility 3. We need a revolution. This is the most speculative path. It suggests we don't need to tweak the model, we need to rethink it entirely. This is the path of new physics. What could this look like? Some scientists have pointed to these findings as potential evidence for alternative theories of gravity that modify the work of Einstein. Such ideas could potentially explain cosmic acceleration and rapid galaxy formation without needing dark matter or dark energy at all. And finally, there's the most profound possibility, that the universe is simply older than we think. This would solve the timeline problem, but it would create a host of new conflicts with other precise measurements.
In a time of crisis, however, no idea is truly off the table. As Adam Rees said, this is a challenge, but also an incredible opportunity to learn more about our universe. We are living in a pivotal moment for cosmology. The James Webb Space Telescope, a machine built to provide answers, has instead given us a profound mystery. The simple, elegant story of our universe is facing its greatest challenge yet. The discovery of unexpectedly numerous and matured galaxies, combined with the stubborn Hubble tension, has brought science to a critical juncture. The warnings from Nobel laureates are not a sign of failure, but a declaration of opportunity. They signal that we may be on the verge of a scientific revolution that could rewrite our understanding of space, time, and our place in it. The universe is more complex and surprising than we ever imagined. JWST hasn't shown us that we got everything wrong. It has shown us there is so much more to learn. It hasn't closed the book on our cosmic story. It has revealed we've only just read the first page. If you found this journey to the edge of human knowledge interesting and informative, let us know your thoughts in the comments. We'd love to hear from you. Thank you for watching.